Okay, the last problem actually in our guided notes is going to be number 436. 436, it says we want to determine the reactions at A and D when beta is equal to 30. So the illustration we're looking at is right down here. Okay, and beta is the angle that the 150 newtons makes with point C. So this is an applied load, and that beta is the direction that that's going to be. So we have a support at D, and we have a support at A. So we're going to start by creating our free body diagram, putting our applied loads in place, our, all of our dimensions, and then we'll, look at specifically A and D on how we're going to represent those as supports. So I am going to here scooch this in a bit. And we're going to start by putting our convention upper left-hand corner. And then we're going to draw our free body diagram. And again, this is our free body diagram. So I'm going to draw like this T bracket. Over at D, support, and over at A, we've got another support. And at C, we've got 150 newtons, 30 degrees to the vertical. Okay. So this is what I have based on the applied loads and the distances. I need to fill in the supports at A and D. So at D here, we look at our figure, you'll notice that it looks like pin connection, right? So we know from page 160, a pin connection is going to have an X and a Y reaction. So at D, we're going to show a DX and a DY. And again, we're going to assume a direction because right now I really don't know. Okay. So I'm going to say DX, and I don't have the answer key in front of me, honestly. I'm working these right along with you. So that's a pin X and Y. At A, as we look, this looks like a roller. Okay. Now a roller, we're going to have one reaction perpendicular to the surface it's riding on. The surface it's riding on is vertical. So that means perpendicular to that, our reaction is going to be horizontal at A. So I'm going to show that, and I'm going to show it going to the right. Again, I am not sure, but I know, actually it doesn't have to be an AX. There's only one reaction there. We can just call it A. Okay. And those are our reactions, okay? Now, as you look here at C, this is an applied load. So it's at an angle, it's not vertical or horizontal. So we need to know its components. So we're going to have to do a CX and a CY. Okay. We know this is 150 newtons. So we're going to have a Y component. So this is going to be my CY. And then we're going to have an X component. Going to be our CX. So that means that we need to do components, right? I'm gonna scooch them over here because I want to try to get this all on one page if I can. So I'm gonna do my components here. Okay. So CX is equal to, our angle is here, 30 degrees. So that means that the X is equivalent here. It's going to be the side opposite. So it's going to be sine 30 times 150 newtons. Okay. So our CX, so watch those angles, okay? Because I know we don't want to get too used to the cosines are the X's and the sines are the Y's, because in this case, it's not. So 30 sine times 150. So that's going to be 75 newtons. And our CY is going to be the cosine side adjacent of 30 degrees times the hypotenuse, which is 150. So CY is 0.866, 150 times. So we get 129.9 newtons. All right, and those we have definitive numbers for, so we can use those. We don't have to put them in terms of the hypotenuse. All right, so that's step number 2, right? So our step number 3, oops, is that 290 millimeters? Yeah, oh, look at that. Thank you, Tim. That paper is a little shiny. Yeah, 280. Thank you. Thank you. Thank you. Thank you. I'll double check right now. This is 100 and 180. Okay, 280 there. Thank you. Thank you. Now we're ready for our equations of equilibrium, right? So step number 3, equations of equilibrium. And we've got 3 of them. So we might as well start with sum of the forces in the x equals 0 and see what we get. So you'll notice that I have a positive AX, a positive A in the x direction. I've got a negative DX, and I've got a positive CX, which is 75 newtons. That's my sum of my forces in the x. I set that equal to 0. 2 unknowns. That's all I can really do there. So we're gonna leave it just like that. I'm gonna do the sum of the forces in the y and see how far we get. Sum of the forces in the y equals 0. Now we're gonna look up here. I've got a negative CY, which is a negative 129.9 newtons. Okay, coming down. And we've got a positive DY equal to 0. Well, that's promising. I put that to the other side. I've only got one unknown, right? dy is equal to 129.9 newtons. Yay. Okay. And then lastly, I've got one more equation of equilibrium. Now I know my dy, right? So I still need to know my dx and my a. So when I sum my moments, I'm going to leave a little room here because I'm going to have to add in. I'm going to sum my moments. I need to decide, what do I want to sum my moments around? Do I want to go around A or do I want to go around D? I want to do one of those two because that's where my 2 unknowns are, right? So you guys tell me, let's vote. Or whoever I hear first. A or D?
D.
Did somebody say B?
D.
D. Okay, thank you. Thank you. That was one of the choices. Yeah, let's go around D. Okay. So this is our last problem. I'm gonna let you go around D and see what you get. Okay, how about that? And I'll do it down here as well. So at this point, you're probably like, I got this. So that's what we're gonna do. So I'm gonna go ahead on the side here, put my finger on D. You're gonna see me rotating around, but you guys go ahead and do it yourselves. I'm not gonna talk. A little bit so you can see it. Well, only unknown here is A. Double check that. End up with a positive value for my A, so that means I assumed the correct direction, and it is 243.7 newtons. And then anybody who's gotten this number, just let me know. I did check mine. I'm quite
I
certain.
got it.
You got it too, Nick? Thank you. Awesome.
I also got it.
You also got it? Awesome, thank you. Any questions on, moments? We've been working on moments in module 4, module 5 here, and usually it takes a little bit of time, but by now you should be starting to like understand, first of all, the rotation, but then also the distances. Any questions on any of these items here? Force times distance, or the sign? Okay. Once we have our A here, now we can use this, substitute it back up into here to solve for dx. So go ahead and do that. Ended up with a positive value one more time. Our dx is 318.7. 318.7. Right. So same process again, free body diagram, components, and then our 3 equations of equilibrium to solve for any unknowns that are at our supports. Okay. So that is problem 436. What I want to do next is go over the application problems. Okay. So I'm going to stop here and I'll start a new recording for an overview of those application problems.